This sounds like one of those things that they're talking about that make you look like embarrassed or something, but that was a straight factual statement. This is what they want people to think is stupid.
Well, like he says, Bev and only deals with surveying, and that surveying is 3D. Reality is 3D. We've always said that. We definitely are not 2D Earth. Whereas...
No, I'm not either.
What Brian's saying here... I'll go one more. Let's listen.
Go ahead, Brian. Well, 1 second. When Bev is referencing measurements, he's purely focusing on surveying. Said the last time I was on, surveying deals with 3 dimensions, right? Length, breadth, and depth. Whereas when it comes to celestial navigation and aerospace, we're only dealing with length and breadth, not dealing with depth. They're not dealing with elevation changes. So when Bev speaks about measurements, he's only speaking about them from a surveying point of view, which will be elevation changes.
Yeah, it's 3D. Reality, yes.
But he's still contradicting himself because he's talking about this angle measurements on vertical plane. They measure by that elevation changes because these stars have different angles, so he is measuring elevation changes.
Yeah, elevation profiles measure elevation changes of the land. But that's the 2D plane that they're working in.
Elevation changes. So when Bev speaks about celestial navigation and aerospace, we're only dealing with length and breadth, dealing with depth. They're not dealing with elevation changes.
Right, yeah, so they're not dealing with elevation changes.
So this is nonsense.
Yeah, I think it's nonsense. I don't think he understands what he's talking about. Because of course they're dealing with elevation changes. Unless you're talking about like a map. But even maps have contour lines on them.
So he's thinking about just putting his arms out and pretending he's an aeroplane, I think.
I'm struggling to try and work out what he is, right? It's one of those moments where you have to believe that he's talking nonsense because I can't make any sense out of it. And if Brian wants to come and try and help us make sense out of it, then be my guest, pop in, come and have a chat. But I can't make any sense out of why Brian's saying this. The reality is 3D, and that's what Bev's talking about, but they're not talking about that.
And by the way, this is 2D he's talking about is not horizontal. He's talking about vertical plane, not horizontal plane. So it is 2D, but not horizontal. But only horizontal proves flat Earth. Vertical disproves flat Earth. Complete nonsense. He's arguing nonsense, against himself.
Yeah, that's what's some of the magic tricks within this is that these guys have developed this paracosm that they've lived in, where they just get used to talking nonsense to each other. And I think that's why Nathan Oakley hands this off to somebody else, because he can't really talk the nonsense because it doesn't really make any sense to him. So he hands it off to somebody else, but when that somebody else is also talking nonsense, this is what you get left with. It's mad.
So when Bev speaks about measurements, he's only speaking about them from a surveying point of view, which will be elevation changes.
No, Brian, right? Well, the thing is, when you have a point, you locate it on the horizontal. Right, that's your X and your Y, your grid position. You then can give that a position on the vertical datum also. There's a location marker, and then it gets placed upon the vertical datum also, that position. That's the way it works in reality. That's what surveyors do. We know that. We know how these measurements are taken. We know how the benchmarks are transposed from one position to another. And Nathan should too. How difficult.
It was okay when I said to him, I said, a bed was there, and I said, there's no better book.
And this again, right? Listen to the words that Brian uses. It's pretty sad, Brian. Pretty sad. Right, but you might have got the impression that he said it to me. He didn't. He said it to Elderbear. And I was in the room. But he wasn't addressing it to me. But now he seems to be addressing it as though he was addressing it to me, although he just said it in the presence of. But listen to what he said.
There's no better, more correct way to describe the Earth than flat.
Not flat. It's more. It's a little. It doesn't give you much more information, but it gives you more information than flat. Because flat is a lie, and not flat is vague, but it's not a lie.
You would have to call yours altimeter globe proof.
The what?
No, because there's difference between the two globes. Altimeter is not a word.
Yeah.
One would be penultimate,
Yes,
the other would be ultimate. But theirs is the ultimate dogmatic globe proof.
Yeah.
We're doing the ultimate real globe proof. Two different things.
I know it's not a real word. It was supposed to be an unfunny joke, but what's the difference between the dogmatic and real, the actual globe proof?
Do you know what
One's
dogma
real.
is?
What's? Can you repeat that again?
Do you know what dogma is?
Yes, I know.
Okay. So there's no proof, is there? Otherwise it wouldn't be dogma.
But nobody said it's a dogma. I mean, you did,
we
but
did.
you
Yeah,
have no basis to back it up.
Yeah, that's what their proof is, right? The ultimate globe proof, as presented by Jekyll and Manufactotum. Do you accept
why
it?
is it a dogma?
Is it also EMBO's ultimate globe proof?
Yes, I accept it.
You accept it.
Yeah.
Is that because you didn't actually have one for yourself, or
No, it's because I looked at it and I got convinced. Like, I'm not. I don't have to invent an argument by myself to recognize that something is good and logical.
You could though, right? Surely you must have already had something in place, because that's why it's the ultimate globe proof, right?
Yes, I have many of the globe proofs, but they weren't like logical syllogisms. They were more like just arguments from real world, and you seem to like more the field of logic. So that one is heavily based
Logic
on
is
logic.
where the proof is, right? Or is there somewhere else where we can get proof from?
Yes, like ultimately logic is the only thing that can prove things, because logic itself is an separate language from reality, so you don't you can't get any outside factors or conditions. Yeah, you can't get like outside factors or conditions that could alter your evidence, because for example something else could cause it, like in reality, because logic itself is an isolated like kind of language. So you can prove it in logic, but in reality, if you can apply logic to reality, but you have to be aware that some other conditions can always alter your proof, so it becomes more kind of evidence than proof.
That sounds very anti-logos.
Well, yeah, I didn't know.
Why?
Like, if logic's there, like, where's the bit that logic isn't? Because that's the bit that I think we're looking for.
Let's say, for example, the black swan argument, which says that if
wait a minute. The fallacious modus tollens that QE calls the black swan.
yes, exactly, but it isn't fallacious because the argument itself, the syllogism, is fallacious. It's because its premise is invalid. Because he says that if the Earth is a globe,
has
then
a radius.
yes, exactly.
It's
So
the fact
he
that
says
he changes the P when he does not P at the end. So modus tollens, right? And modus tollens is if P, then Q. If not Q, therefore not P. Right? Well, the P has to stay the same. You can't change it. And that's why the fallacious modus tollens that QE calls the black swan is fallacious, because he blatantly just does a switcheroo of his P.
Yes, I've heard about it, that
But
he changes to...
that's the trick, right? Because the flat earthers that listened to QE took it on as though it was an actual argument. And like you here as well, you've took it on and not noticed that either. And you're still trying to rebut the argument when it's fallacious in form.
Actually, I noticed it. I mean, not by myself. Yui told me it, and yeah, he changes the
Well,
the
we
P
told
at the end.
Yui as well, and this is like after like what 4 years of us telling people, like, what's up?
But
Have you just started drinking distilled water? What's the change? Why didn't you notice it when QE brought it out?
I have no idea. Like,
It's like a magic trick.
I think
It's like QE's a sort of magician, right?
I think people didn't, on the globe side at least, they didn't notice it because they were focused on exposing other kind of invalidity in that argument, which is ignoring refraction. That's why they didn't notice the other kind of validity, because they weren't really focused on it. But my point is that even assuming that we fix that argument, we change the conclusion to the original P, which is that the Earth is not a sphere with that set radius, and not that the Earth isn't a sphere at all.
Okay, well, can I just add in then, right? Here's the other one. Do you think it's a blade?
Yes, I think it.
So it doesn't have that radius anyway, does it?
Yes, it would be like an approximation.
So it would be a fallacious statement to say that it does, when even you know it doesn't. I mean, I think QE knows it doesn't either, right? I think we all know that the actual radius is unknown.
I wouldn't say it's unknown.
Sorry, wait a minute. Unmeasured.
No, I would disagree with that, because even if you have an oblate sphere, then you can use some geometric formulas to calculate that radius for given latitude, because you have that measure that
would
radius.
Remain unmeasured.
But why?
Because you've not measured it. It cannot be measured, the radius, because you do realise the radius comes from a centre, and you can't get there. So, unmeasured. It's an impossibility to be able to measure it.
Yes, if you want to get that precise, then you could call it like it was calculated instead of measured. Because if you measure, if you define measurement as a direct measurement, that you take a measuring tape from one point to another, then obviously you can't measure it like that. But you can calculate it using other geometric factors.
Well, that's the point in, like reality, right? The measurement is the identifier of the unit. That is all. Now, you can get as precise as you want, right? Within modern standards or whatever, right? But that distance, that measurement is all important.
But why? If you have some method that isn't
Why
based
is
on
the
direct
measurement
measurement,
important? Do you know, have you heard of pi?
yes,
Right, do you think that's important?
yes, I think
Well,
definitely.
how do you get that?
The pi number,
Well, just
uh,
pi.
pi
Yeah.
is that if you have a circle with the radius of 1, then pi will be the circumference of the circle with that radius.
Mm-hmm. Well, that measurement of the 1 is vitally important to get that you want to call pi, isn't it?
Yes, definitely.
But if
But
you can't
you
measure
don't.
that 1, then how do you know about the pi? Like, so the measurements are known because pi's known, right? Or the relationship of pi being a not number, right? It's just pi because we know that we can't get the number, right? We can't do that, is the message, right? But similarly, you can't measure the distance of your radius to any sort of tolerance because you can't measure from point to point.
Yes, if you again, if you define measurement as a direct measurement, then of course. But I would say then that even if that's not a precise definition, then if you have some kind of like experiment where you calculate a value, your target is calculating that value.
That's geometry
But
then, right?
yes, but the
You're doing
steps
that
you have
entirely
to.
through geometric reasoning, logic.
Yes, but the steps you have to take to get that value from geometry, you have to measure some other factors that you know that have relationship
Yeah,
with
well,
that
that's the
other
whole
factor
point
you
of
want to
what we were
calculate.
talking about, is that there's a logical step to find those geometric calculations for the things that you can't measure, right? To be able to do these things. But so you have to follow the chain of logic. At no point is there any break from that chain of logic.
I don't think there's a break
No, there isn't.
in our reasoning. Yeah.
That's where proof is. Similarly with science.
So you think that science proves things?
I think that you can prove things to yourself in reality.
How would you eliminate like some other factors that could impact your results in reality?
Make sure you can
Because
make a good argument for your proof.
yes, but you know that proof from definition is something that is like 100% sure. But in reality, there could always be an infinite number of explanations for the same phenomenon, even if most of these explanations are ridiculous and require a lot of assumptions. They are only rejected because that number of assumptions, that's called the Occam's razor, that the explanation with the list of assumptions that is the most simple tends to be the most true one. But like you can't ultimately prove that the most simple explanation is better than the other ones, because if you have some get some greater amount of scientific knowledge and data, then you can always find out that your previous explanation was wrong and more complicated things are there.
Well, 2 questions. Do you drink distilled water?
Distilled water?
Yeah.
No.
Okay. Question number 2. Do you actually have a proof?
Proof for what? For that
Anything.
I don't drink
Anything.
anything. Yes, I can prove, for example, that let's say if you have the, for example, Pythagorean theorem, I can prove that. Let's say.
How? How would you choose to prove the Pythagorean theorem?
Well, I would construct the squares made from the sides of the right triangle, and I will prove that the area of these squares, of these smaller squares, equals the area of the bigger square.
How would you do that? That's the idea. How would you prove it?
Well, by simply measuring their sides, for example. Like taking a ruler and measuring it.
How would you prove it's straight?
It's straight.
Mm-hmm.
That comes from the definition. If you have a triangle, then it has to have the straight lines as sides. So that's kind of like what information you're starting with in the first place.
Oh, you got a pre-assumption of straight.
Yes, already. Yes, because we're starting with a right triangle. That's something that we have, at the beginning of the problem. So we're starting. So if you have the triangle and you have the knowledge that is a right triangle, then already different things can be derived from that definition itself. That, for example, the one of the angle will be 90 degrees, or that the three sides will be straight.
Mm-hmm. What if somebody told you can't have that?
That I can't have that.
Yeah.
Then the entire issue would be pointless in the first place, because Pythagorean theorem only works for right triangles, and if I don't have the right triangle, then proving that Pythagorean theorem would be pointless.
Oh, sorry. Wait a minute. You can't have the right angle being horizontal and vertical. That was it. In reality, right? So that's the point. How would you prove it in reality if you were to do a reality proof of Pythagorean theorem?
So like you mean like in with physical objects?
Yeah, we were talking
like
about
sticks, for
proofs in
example?
reality, weren't we? I asked you if you actually had any proofs.
No, I was just speaking about geometry.
Yeah, that's what I mean. Now, the whole question was due to if you have a structure that says there is no proof within science, how would you relate the proof from geometry to reality? Is that where the proof breaks down? Like, because obviously you can prove the Pythagorean theorem within a geometric system, but I mean, you want to relate that to reality? Apparently, people say you can't. Like science, you can't apply that proof from mathematics to the physical world for some reason.
Yes, you can, but in that case, that proof would change to evidence. Because if you apply it to reality, even if you do it with direct measurements, showing that there's a right triangle, then that could be altered, for example, by when you're looking at these 3 points, the distance that make that right triangle, the light from them could bend, for example.
Well, you
So
could
the physical
reciprocate it,
phenomena.
right? That's the point.
Yes, but the
The
physical
right
phenomena
triangle
that
could be
happen in reality.
reciprocated about the, let's call it horizontal. But geometrically, that would cause problems, wouldn't it?
What would be the problems?
Well, if you start off with a vertical and then you get a horizontal, yeah, you've got a right angle.
Yes.
And then if you reciprocate that about the horizontal, then you've got a vertical and a right angle to the horizontal again, haven't you?
Yes.
Well, that's problematic, right? Is that why you can't apply the Pythagorean theorem to reality? Because you'd be able to disprove it, wouldn't you? As pertaining to
No.
horizontal and vertical. At least if you were willing to accept the horizontal paradox. Perhaps you've never even heard of it.
No, I haven't.
No.
I think I'm backwards in the topic.
Yeah, it's problematic proof in reality, new modern day.
So what's that paradox?
Paradox.
Yes, the horizontal paradox.
Well, I just explain it then.
Oh,
You can't reciprocate a horizontal vertical perpendicularity in reality, right? Can't be done. The shortest distance between 2 points at an equal elevation cannot be a horizontal. The paradox is, what do you call it?
Yes, if the Earth was a globe, then definitely it wouldn't be horizontal.
Shortest distance between 2 points.
Yes.
You'd think it would be a horizontal, wouldn't you?
It would be a horizontal for a point, because horizontal in the first place is a relative direction. Like for every point on Earth, horizontal is perpendicular to the direction of gravity, so vertical. So if you have 2 points, then the horizontal line, the line connecting these 2 points would be horizontal for a point that is at the middle of these 2 points.
I
don't know
I
if
did
you
that
understand
repeater the
that.
other day. If you were to put a line from A to B from those 2 points, and then place a perpendicular at the center, as if you were gonna, divide the line in two. Have you ever seen that? Geometric, how to do it?
Yes.
You make like a vesica Pisces and draw a straight line, and it sort of bisects the line perpendicularly. Yeah.
Yeah, so that line would be horizontal only for the point directly at the middle between
All
these
of
2
the
points.
perpendiculars to that line would be parallel to the horizontal, wouldn't they? All of them.
I'm confused.
If you were to draw, you get 2 points at an equal elevation. Yeah?
Yes. Are we assuming the Earth is flat or a globe now?
We're just taking this as 2 points in reality.
Okay.
Okay. Now we're just going to draw a straight line between the two of them, and say, I'd
Okay.
say there's no slope to that line. Right? No elevation change to that line. I'd call that a horizontal. Now, if you were to perform a perpendicular, or demonstrate a perpendicular at the center point, yeah, you would call that vertical.
Yes.
Okay. Now all of the perpendiculars to that vertical will be parallel to the first horizontal that you had, or the first line from A to B, wouldn't it?
Yes, definitely.
And
okay,
a line
I understand it now.
Doesn't change in elevation, has no slope, is called a horizontal. And all horizontals are parallel to one another, so all of those lines would be horizontal. Even the one from A to B that you said was only horizontal at a point, but it seems to be that the line from A to B is entirely horizontal. All of it. Not just one of the points. All of them.
Not really. I will have to. I'm drawing it right now to have some better insight of it. But if you want, I can send it in the chat to have some better reference.
I posted something for you there in the live chat.
So let's say you have these 2 points and A, B, and you on a sphere, and you connect them with a straight line between them. So
What's the
according
circle
to the
for?
definition,
You want
the
to be doing
circle,
your circle from B and A in order to get you perpendicular to the line.
the circle is the Earth.
What?
Yeah. If you assume the Earth is a globe, then that's how it would look like.
Okay, that's how you do it. Okay then. So yeah, we've got AB and we've got a straight line. It looks dead geometric to me. I look at this as though it's just geometric.
Yes, so if you assume the definition of horizontal as 90 degrees from the vertical, then you can see that the only vertical that fulfills that definition is the vertical at the point C. And that point C is directly between and AB.
No,
But
I mean,
for A
I
or
don't
B,
know.
that wouldn't
I've got
work.
no more points, but the vertical line that C is, right? That entire line AB is perpendicular to that line in the center, right?
Yes. Yes.
Okay, so if you want to
That's my
call
point.
that one that's vertical in the center a vertical, then the line AB that's perpendicular to the vertical is horizontal, because that's what we call a perpendicular to vertical, a horizontal. So that line AB, when the C is orientated vertically, like it is going to be called a horizontal.
Yes, but it would only be horizontal at C, because
No, the entire
the
line's
vertical.
horizontal.
Yes, the entire line is horizontal.
Is perpendicular to vertical.
My point wasn't that the line changes, like it stops being horizontal at some given point, but that you have some reference, it's measured as horizontal relative to, and if you change that reference, that the entire line stops being horizontal.
What, the horizontal line
Because
stops being horizontal, even if extended
yes,
indefinitely? Where, at what point does the horizontal line, that horizontal line, stop being horizontal?
if you start walking away from the point C,
You
for
don't
example,
walk
on
on
the
geometry. It's like this A, B, and C. Yeah, you've done that. They're there on your drawing. C is the intersection point, is it? And A and B would be points at the end of the chord.
Yes.
Okay.
So if you, for example, take the line at
we did
A,
say that, you know, like they were at points in equal elevation, like in reality, didn't we?
Yes.
Okay. But you chose to draw a circle.
Okay, so I would have to change that. But in that case, the line connecting the A and B wouldn't be horizontal anymore.
Right. Can I just check now? This may sound really weird, but we've just going over. I'm cutting a video. My mate Spot On has done some music, and he's also put like this little clip. And I think he does this to sort of keep us reminded and focused on certain things, right? But we're in that there's a conversation where Brian's logic. Have you heard him?
Yes.
Okay, now he's a flat earther, right? But when he says that they only deal in 2D, he sort of shows us this vertical picture like this. Like he makes you look at an elevation profile. Right now, an elevation profile is on the vertical plane as your picture is there, right? Because I'm looking at it on my TV screen. I'm looking at it as though it's a vertical plane. So
no,
is this a similar
elevation
sort of thing that Brian's logic does, that you're doing right here, and not seeing the reality part of it when we're talking about 2 points at an equal elevation, right? That's obviously in reality, but you chose to draw a circle. Like, I mean, does that circle relate to reality as an equal elevation? I mean, I don't
Yes,
relate that to reality.
I think the measurements in reality show the Earth to be a sphere, but if you have a problem with operating in 2D, then we use 2D as a
Which are
representation
the
of.
measurements in reality then? Which are the measurement from A to B between
Have you
these
heard
two points?
Have you heard, for example, of something like triangulation network?
Yeah, like you said, there's straight lines. Yeah.
They make triangles, measure
Straight
triangles
lines.
between points on Earth.
Yep, straight lines, like you said. Shortest distance.
Yes, and the angles in these triangles happen to add to more than 180 degrees.
Impossible.
Why?
Because it's literally impossible. All triangles have 180-degree internal angles.
Only if you have the planar geometry, but if you have spherical geometry, then you add to more than that. And if you have the
But we're using
like
straight
concave
lines.
geometry, hyperbolic geometry, then they have less than that.
Yeah, but we're using straight lines, aren't we?
But yes, we do. But straight line
you
on
said that at
a
the
sphere is a circle. But straight line
What
on a sphere is an arc.
Where was the flip? When did we change from straight to not straight?
On a sphere, shortest distance between two points is an arc.
No, the shortest
On the
distance
surface of
between
a
2
sphere.
points is a straight line.
Yes, and straight line is an arc on a sphere.
No, a straight line is a straight line. An arc on a sphere is different. You seem to have a problem with the law of identity. And if you have a problem with the law of identity and that problem is straight, then you've got a big problem.
So, what do you think is the definition of straight?
What, the definition? If you just Googled it, it sounded
Yeah.
like we could hear your keyboard going.
Yes, the definition of straight.
Oh, let me have a look.
What was yours?
Yeah. Do you have one?
Before,
Oh,
you looked on Google.
bad. That spot on. Bad connection.
Oh, we got a new guy. Hello, new guy.
Hello?
Here we go. I think I've got a definition of straight. It says a right line is that which lies evenly between its extreme points, that is, without curvature in any direction, being the shortest path between those 2 points, never deviating from that path.
Okay, so if you have a curved space, like for example a surface.
T-shirt logic on the level. .live.
Like if you have a curved space, like the surface of a sphere, then how would you draw a straight line on it?
That's the straight. You only know it's curved by referencing it to the straight. It would be a violation of the law of identity to state that the straight line is not straight, because obviously it's straight.
No, if I was if I lived on a surface like that and I had the line that would be curving in another dimension, but I would be like inside of that space in that 2D, then I would.
See, here's the problem. There is only one dimension to a line. So how can you curve it in another dimension?
Because the space it's in is curved.
Straight is curved.
Yes, it would be curved if you like took a look from the third dimension, but if you only stay in that space, you would perceive it as straight.
Yeah, you know, that sounds like gaslighting. Or are you being serious? Have you had to do some special work on yourself to convince yourself that straight can be straight whilst not being straight? Because that is some pretty good work. I'd call it diletheism, I think. Well, I would, yeah. I'd say that's a healthy dollop of diletheism. The thing is, have you taught yourself how to do that, or has somebody else taught you how to do that?
No, somebody else. Like
Somebody taught you how to do it.
Yes, I think.
Who is your teacher?
Who is my teacher? The internet.
Uh-oh. Not YouTube.
Not YouTube.
Oh, good.
More like Google, but I think saying that you got some knowledge from external source isn't the best argument to debunk that knowledge, because I think most of our knowledge we didn't come up with it by ourselves.
Lead to conspiracy theorists. People getting carried away with things. I mean, it's not saying it's not a bad thing, right, to go and research stuff, but I think you know, like your peers, do you take criticism well?
Criticism?
Yeah. You know, like if people challenge you, are you okay with that?
Yes, I don't care about criticism. I don't really care about what people think about me. If I did it not, then I wouldn't be in this community, because there is a plenty of rude people here. Not in this specific one, like on this server, not that I accuse anyone, but in Flat Earth in general, in Flat and Globe debate.
Globe debate?
Yes.
Can be a lot of fallacious stuff, isn't there? I mean, like, you guys claim that there is no proof, so, I mean, there is no debate, surely. You can't debate stuff.
I was going to kind of say that. I was going to say, aren't you going to need a globe for the debate?
Well, no, you just need to be able to debate arguments, and since arguments would get refined down to a point where they would become proofs, you can't have that. So the end outcome of any debate would be some sort of a proof, which isn't allowed. So I don't know how you go about attempting to debate. Not in the traditional debate sense, anyway. I mean, I suppose you could get a load of people like Nathan Oakley to completely change what debate is, because that would help you out, I would imagine.
Yes, if Oakley was in charge of definition of debate, then debate would be one person talking and the rest being muted.
Well, he already has. I mean, he's redefined it. Like, you put flat Earth in front of it. I mean, but who do you think the flat earther is debating? Right, that's you, the glober, innit? So your globe debate has become just as fallacious as the flat Earth debate. It's a
Flat
joke.
earthers
It's fucking
like to say,
ridiculous. And you're
they
just
like
as
to
much
say,
to blame as the flat earthers, to be honest.
but why? What's the problem?
Because nobody bothered shutting the flat earthers down to tell them the truth. What they did was something like you just come in to try and tell us that straight isn't straight. I mean, that's as crazy as a flat earther.
But at least I have some, like, explanations or examples. But when I asked you if you have a curved space, how would you draw a straight line between it, 2 points? Then you wouldn't answer.
Yeah, I would say I've got a realizing Euclid test. But you'd have to go through the geometric reasoning first to be able to relate that to reality. But you can't even understand what a straight line is. We were talking about it earlier today.
Straight line is a line without a curve.
Okay. But what was that you were saying earlier?
I was saying that that line would be curved if you looked like from outside of that space, but in that space it would be straight because the space itself is curved. So, like, let's say you
taking
have
the God position on the straight line, you would curve it.
Yes, like for example, let's say you have a physical ball, like not imaginable, but physical ball, then you can touch, and you put a marker on that ball and mark 2 points on it somewhere on the surface, and you want to draw a straight line between these 2 points.
That's obviously, you're talking about a ball. The ball needs a radius. The radius is straight. Okay, establish that already. So we know what the straight line is to get the ball. You can't stolen concept the shit out of that and say that the line isn't straight. I'm more curious as to how you take that straight line, place yourself in a God position, and curve it. I mean, what purpose does that achieve?
I don't think that has a purpose, it's simply geometry.
No. That's you imagining a straight line from a God position as being something different than a straight line.
Yes.
And yeah, the question is, why do you do that?
Because it's a part of spherical geometry, and spherical geometry is important in different aspects of reality. For example, astronomy or geodesy.
Okay, so the shortest distance between those 2 points is a straight line, right?
Yes, and the straight line
is that an
on the
actual
surface
straight
of the
line
sphere is curved.
or a straight line that looks curved from a God position of beyond the God position that you're already in?
It's both at the same time. It's an actual straight line.
That's diletheism. I did say that. Called it. Have you ever heard of diletheism?
No.
It's yeah, go on, Google it. It's a recent sort of thing in the 1980s, I think, 81. But I mean, you can trace it back to about the 70s, I would say. And it's a way to deal. It's like a cognitive dissonance sort of tablet that allows you to dismiss contradictions. Just sort of, allow two truths, right? Troubled by true or false, take the diletheism pill. You can have two truths.
I would say that it can be a valid objection in some cases, but in some cases it can be misinterpreted as simply rejecting an explanation of a phenomenon that is more complicated than simply true or false. So it would be like a false dichotomy. Someone can make a false dichotomy, and then someone can respond to that and say, no, that's more complicated issue, that true or false aren't the only answers for that problem, and someone could invalidly call out
Yeah,
that
but
person for using
you could
relativism.
call a false dichotomy if you can call both things false, right? You can't call it a false dichotomy because you can provide two contradictory things true, can you?
I think false dichotomy is simply a phenomenon of presenting two explanations for a phenomenon without what explanation is true or false is irrelevant to that. If you simply present two explanations for something as the only valid options, regardless of if they are true or false, then it's a false dichotomy.
I'd say the false dichotomy, the best way to prove it would be to prove both of the options, the given options, false. Because a true dichotomy is where there's one of the choices, right? One of them's true, the other one's false. That's a true dichotomy.
Yes.
Whereas a false dichotomy could be because both of them are false. Therefore, both given options are false. Therefore, a false dichotomy. There will be no truth to be gained from it. It's up to you to see whether, you have the ability to prove things either true or false. But if you have a system where you can't prove anything, at least if your peers have told you that you're not allowed to prove anything, then how would you know whether it's a false dichotomy or a true dichotomy or just diletheism? You could just take it, accept it through diletheism that, it's true. Both true.
Yes, so if you debunk both of the options are as false, then yes, I can agree that it implies that something has to have some third option that explains it, but so it would be a false dichotomy, but it wouldn't be the only possible explanation, because it could also mean that the problem doesn't have any answer.
Maybe, yeah. It's not. You don't have to give an answer or the third option or fourth or fifth options. You don't. In order to prove the false dichotomy, all you have to do is prove both of the options false.
So you believe that you did so with the sphere and the flat Earth?
Well, yeah. I mean, that's easy, isn't it?
What is your? So I've already heard about the bank of the sphere. We were talking about it, all of the horizontals and the verticals and all of that. But what's your debunk for the flat Earth?
Elevation changes.
Elevation changes. So you think that the Earth, if it was flat, then it wouldn't have elevations?
Flat. Yeah.
So you think if the Earth was flat, then it wouldn't have elevations?
I would say, in order to disprove the flat Earth, you just have to show elevation changes, yeah?
Yes, but most of the flat earthers will tell you that it's a straw man because it's not the actual definition of how they define flat. They could say that they, for example, define flat as the plane they measure the elevations relative to. It's not the elevation themselves, it's the reference they measure it relative to. So if you have some bigger elevation, then it wouldn't be at the same plane, but that elevation you measure it to the flat plane in the first place.
Yeah, that's what we were getting confused about at the beginning, because we've been going over it. Brian Leakey, he's the one that said, no, not Brian Leakey, Brian's Logic. He said they only deal in 2D. And then he talks about elevation profiles. And as we know, elevation profiles are a vertical plane, aren't they? They're 2D. They are 2D. The elevation.
No, they aren't. They aren't 2D. They are 3D because
Because they're on
if it
paper.
was 2D, okay, on paper. So if you have it,
The paper's 3D.
no,
Like, everything in reality is 3D. This is what Brian's logic said. He said when he's talking to me and we're talking about 3D reality, we are here. And when we're talking about elevation changes, the elevation changes that we're talking about are in the vertical, right? And he says he's not talking about that. He's talking about 2D because he's a flat earther.
So I explained it pretty poorly. So I try again. You could make an elevation profile both in 2D or 3D, and that would depend, because if you make an elevation profile of a straight line between two points, then you could make it in 2D because you don't have that third axis. You have that elevation also between that axis. But if you
have seen
make
an
a 3D
elevation
model,
profile, haven't you?
yes, but you could also make a 3D model of a path of land, part of land, and that would be a 3D elevation profile because you can see the vertical change, and that's the elevation changes,
that's what
and
we're
you can
talking
also
about,
see the
right?
both of the
That's
axes.
what we're talking about. But Brian isn't. He's told us that. He's a flat earther. He's not talking about 3D. And that's why we say elevation, measured elevation changes disprove the flat earth. Because they're in 3D. It's not 2D. It's dead easy to disprove the flat earther.
That's actually a good point, but that is if you assume they claim that they only operate in 2D. I would say
they are
I
operating
wouldn't.
in 2D. That's what Brian's logic says. All of the people at FED are using 2D. They're not talking about 3D. That's why they get upset, because we keep pointing out that in reality there are elevation changes. And they say, we're not talking about that, we're talking about 2D. So they may be talking about the elevation profile on the vertical plane, because Nathan Oakley keeps wanting to talk about elevation angle, and that's in the vertical plane also. So it's getting really confusing as to understand what the flat earthers are talking about when they say flat. They might just be talking about the vertical plane.
But you could theoretically get an elevation profile in 2D, but in that case you would have to abandon the other axis. As I already said, that would be an only elevation profile between 2 points, the straight line between them.
No, you just get rid of one of the axis of horizontal, right?
Yes, that's what I'm talking about. So yes, if you abandon one of these horizontal axes, then you could get a 2D elevation profile.
Yeah, all of the elevation profiles to date are done like that.
Yes, if you only consider distance between 2 points, but if you...
Any elevation profile will disprove the flat Earth. Because it's a measured vertical change on the vertical datum.
Yes, but these ones operate only in 2D, so your argument about it being 3D isn't valid anymore.
No, reality is 3D. That's where Brian's logic says that we live, us here, not the Flat Earth debate crew. They deal in 2D. That's what we're saying. It's dead easy to disprove flat Earth. They just get upset because they say that they're only dealing in 2D, and we say, well, yeah, reality's 3D. There's another dimension. That's the bit that makes it not flat, and they say we're not talking about that, and we go, well, we are, because we live in reality, and you know, most people can see it's not flat.
Which 2D do you think they operate with?
I haven't
Do
got
they
a clue.
operate like
Literally haven't got a clue. Like, there's not. It's nonsense, mate. Nonsense.
Yes, because there are two options they could operate 2D in. Like they could operate with one horizontal axis and one vertical axis, or they could ignore the vertical axis and get two horizontal axes. And both of these would be 2D. There's actually a good website that makes 2D profiles. It's called heywhatsthat.com, and you can select any place on the Earth by its coordinates or a map, and simply by clicking on the map, and you can take any second point you want to have the line of sight to, and then it would get you the elevation profile of the entire topography between these 2 points.
Shortest distance
And
between
what-
2 points is a straight line, isn't it? I mean, like, most of this
Yes.
stuff's known.
And what's even more interesting is that it allows to model that line of sight as both the flat and the curved Earth. And
What?
if your model is at the yes, I
You
can show it to
model
you.
the straight line.
No, the topography. The topography, like
Well, the
glowing feet.
topography is what it is, isn't it?
Yes, but it depends on what is the reference you measure the altitude relative
No, it's
to.
already been
If it's a
measured, hasn't it? They have
yes,
elevations already measured.
but these elevations you have to plot them relative to something, and if that
An
thing
elevation
is horizontal,
profile normally.
yes, if that thing is the horizontal plane, then that's assuming a flat Earth. And if that is just the sea level, which is around
give
the
us some
Earth.
examples of elevation profiles, will you?
Okay, I can give it. So, where do I share the screen? I
Live.
can't.
No, in live
Sorry.
chat. Just show us some.
In live chat, okay.
Yeah.
So I will have to take some random place. Like, let's say in the mountains. Okay. So it will take like a couple of seconds to make that panorama. You have to generate it on the website. Okay, it's already there. So I have 1 point I selected as a reference, and then I have to select the second point I want to have the elevation profile to. So somewhere like on the fields, so somewhere lower. And
Somebody's having a go at my videos that we put out, live streams, guys. I think it's a live stream. Yeah.
so
Being amateur.
what's interesting? What's interesting here is that you can map this. I will show it in a moment. So first elevation profile is with a curved Earth. This one it's excrugated vertically, because if you had it to scale with both horizontal and vertical scale the same, then it would be too small on the vertical scale to perceive it. So it's excrugated at the vertical scale.
Yeah, on that horizontal, those distances, 120 miles. That's a straight line, right? What everyone would imagine as 120 miles.
And here's the profile for the flat Earth. And what's interesting is that
It's like
that
a
brown
concave.
line.
Is it?
That's my point. I will get to that. So what's interesting is that to model the Earth as a flat Earth and to make it match the observation, you have to map the line of sight as curved, because if you mapped it
in
as
order
a
for
straight,
you to do flat Earth, you have to map it as curved, but you have to map
no,
it
not
as
the
a concave.
not the Earth itself, but the line of sight. So the topography you can see here, like the bumps, is the surface of the Earth and all of the mountains, and you can see it's straight except the elevation. But the brown line is the line of sight between the observer and the point that is being observed, and you can see it has to be mapped as
What, the
curved.
line of sight?
Yeah, it has to be mapped as curved because in reality the Earth is curved. So if you flatten
2,000 miles. What's the 2,000 feet? You look down for, what's that, 60 miles, 2,000 feet, or maybe a little bit more. And then after that, up to 200 and 120, it goes back up again.
yes, that's my point. So
That's
if you have
fucking
to,
crazy,
if you want,
isn't it? How could the flat earthers possibly think that?
they
That's
don't. That's why
fucking
flat Earth is so
ridiculous.
ridiculous.
Yeah.
Because to replicate the results you get from the globe, and in reality, if you flatten that Earth out, you would have to have the line of sight. So like the light bending
Flatten the
upwards.
earth, like getting bulldozers and stuff. Big job.
So yes, you can either have the Earth curved and the line of sight straight, or you can have the Earth flat and the line of sight curved to get the same results. I think the first possibility is more probable, considering that there's no known physics to bend light in that way.
They do know how the land was measured, though, right? Already.
But yes, it's using the geodesy, the triangulation.
Right, so where did you get this flat math from? Is that flat earth math that you've employed there?
So it simply has a known set of topographical changes, which is measured relative to some reference, and on the upper picture that reference is like the center of the Earth.
Where's the
Earth will
one
be
that
curved.
they did in reality?
The reality, I would personally say the upper picture matches the reality more.
Why? Because it's like straight lines from between points.
Yes, because it's more probable to have a relatively straight line of sight.
Horizontal and vertical.
Horizontal and vertical.
Mm-hmm.
These two would be different for every point on that elevation profile.
Okay, so if you were to have a horizontal plane,
I just noticed something weird about this elevation profile.
When we're measuring these elevation changes.
The horizontal plane. So on the lower picture, it would be like the same for every single point, and on the upper picture, it would be different for every point. And
what,
they
the
wouldn't
horizontal
be parallel.
plane? What do you mean when you say it would be different? Because horizontal plane, right? All of the points on the horizontal plane are all like considered to be points on a horizontal plane. They're considered similar in the respect that they are on the same plane, right?
Yes, if the Earth was flat, then all of the points on the same elevation would be on the same horizontal plane.
Okay. Like reality.
No, I don't think that works like that. The theodolite measurements show otherwise. But I noticed something weird about this elevation profile, probably something of bug, because
level?
the observer is for some reason assumed to be at the sea level, even though he's at the middle of the mountain, so he would be looking from below the ground. I would have to fix that. I don't know if you see that, but at the left you have the observer at the 0 altitude, like somewhere 6,000 feet below the ground. It's pretty weird.
It does look like he starts off at 0 and then he can look like near 2,200 feet up through the ground to end up looking higher.
Yes.
That's the line of sight. That's flat earthers must be fucking crazy. Can you imagine that? And thinking about the 2D thing as well. Is that flat earth math?
I wouldn't say that's how the
math. If that's good.
That's how the flat earth. That's how the flat earth mathematics would look like if the earth was actually flat, but they hate making predictions by themselves. They only talk about the globe because they are aware that their own model can't make any predictions, so they only treat the flat earth as a kind of buzzword for falsifying the globe, while they don't make any claims about themselves. So they would call predictions? That. Yes, they would likely call that a straw man, even though that's literally based on the flat earth.
Like a crystal ball.
No, just predictions are based on geometry or physical laws.
Well, predictions like a...
Not a crystal ball.
Yeah, that's making predictions, like scrying. Sounds a bit witchy to me.
But if you make a model which doesn't make even any assumptions beside the pure fact that Earth is flat, they would call that a straw man nevertheless, because they hate the flat Earth, even though they are flat earthers. They only like shitting on the globe, but they know their own hypothesis can make shit.
Well, wouldn't technically all of the shit be on the globe?
In reality, I think all of the shit is on the globe. That makes the observation much the best.
Yeah, pretty shitty situation, don't you think?
Technically, you could have a shit on a plane. Wouldn't be technically on the globe, would it?
In theory, you can, but I think real measurements debunk that.
I think at some point on the chain, though, all the shits would go to the globe.
So, for example, would you agree that the tool theodolite can establish a horizontal plane?
Well, no, I'd use a level.
A level?
Yeah.
Doesn't a theodolite contain a level, a spirit level?
No, not really.
So how does
theodolite's an angle measuring device.
Yes, but to measure these angles precisely, it has to have some reference to measure it from.
Yeah, you just have to set it up on the azimuthal plane.
Yes, that's what I'm talking about. The azimuthal plane and the horizontal plane is the same thing.
Yeah.
Yes, so you agree that theodolite can establish a horizontal plane.
Well, yeah, but not as accurate as an auto level, right? It's like, although it can, it's just for measuring angles within the horizontal plane, right? It doesn't like establish a horizontal plane like an auto level does for establishing equal elevations. It just for purposes of measuring angles. Because when you do triangulation, right, there's many checks. You have to do these measurements many times to establish them. When you establish a level, you don't have to take like 16 shots from different positions just to make sure your triangulation works. Two different things, really. There's establishing your location on the horizontal plane, and then there's establishing the elevation of that point on the vertical datum. two sort of separate things. Although they have incorporated total stations to be able to do all of that sort of stuff. Ish.
So why do you think it's so widely used in surveying as the main equipment if it isn't so accurate?
But they use total stations more nowadays. It does both.
Yes, but
So-
a total station is just a more advanced version of a theodolite, if I
and it's got to
remember
incorporate
correctly.
in the auto level and the GPS system.
Yes, that would make sense. I think some of them also have the, I don't know how it's called, but it measures distances with a laser.
Yeah, through all of the means that they have, triangulation, lasers, the prisms that they use.
Yeah, so all of the modern technology.
Pretty good high-tech shit. But when you bring it down to advanced simplicity, you're just dealing with a location on the horizontal plane and then giving that a position on the vertical datum.
All right, everyone.
Just as we do it, you know. Oh, hey up. First video of the Fitzoid KR channel. Fitzoid KR. That's a badly named thing, isn't it? Must have some sort of thing. Uh-oh. He's semi-naked.